Hi, Fox. Uh, Recently, I shared with you a couple of short videos in which I told that my test bench power supply 0 to 30 volt and 0 to 3 ampere test bench power supply made in China became faulty. So actually, this is a test bench power supply which was became faulty, and basically inside it is this controller board. This is an analog board and linear control. It implements linear control, and instead of repairing it, I replaced the hardware totally. Some hardware I built on very board, while others I purchased. So another benefit that I now having, that the accuracy is very stringent. I mean very tight, and as compared to the linear board, which was not controlling it very tight, and the voltage was varying 1 or 2 volt above or below to the desired value always. So instead of repairing, so I thought I should replace it. I replaced the hardware, and also in this test pen power supply there was a voltmeter on front side. The left side indicates the current and right side indicates the voltage. But I had to replace this voltmeter as well, because the potentiometer that I introduced in this test pen power supply modification was slightly larger size, and so the PCB was not the voltmeter PCB was not allowing for that margin. So I replaced the voltmeter as well, and as before, there were 4 potentiometers in the test pen power supply: two for coarse control voltage and current, and two for fine control voltage and current. And there were two LEDs, one indicating the constant voltage mode and other the constant current mode. I have replaced these 4 potentiometers with the only 2 potentiometers, one indicating the voltage and other indicating the current. However, because I replaced these 1 ton potentiometer with a 10-ton potentiometer, I mean the potentiometer which can be rotated in one direction 10 times throughout 360 degree. So the accuracy is much better. And for other the 2 potentiometers, I replaced them with the panel mount LEDs instead of mounting on the PCB. So this was a previous board, and now let me show you the working of this power supply. So if I can show you, uh, this is the constant voltage indication LED that I installed on the right side instead of potentiometer, and on the left side I installed constant current LED panel mount. So these two LEDs indicate in which scenario we are operating. I mean whether it is voltage mode, constant voltage mode, or constant current mode. And the 2 potentiometers that I replaced are the 10 tons multi-ton potentiometers, one for left side for current adjustment, and right side for the voltage adjustment. The current adjustment I have set it to 4 volt 4 ampere maximum, and by default it was, I think, 8.2 ampere or 10 ampere. So I changed the resistor value, and now it's not going above the 4 ampere. and the right side potentiometer is indicating the voltage, desired voltage, and because it is multi-turn, so the accuracy is very high. So let's power it up. So I have connected it to the mains socket. So now I powered it up, and at the moment you are seeing 1.2 volt on the output. It can in the red color. Red color shows the voltage and the blue color shows the current. And current is at the moment 0. So 1.2 volt is the minimum voltage, and if I increase the potentiometer value, you can see 7.5, 8, 9, 10. You see it is very accurate. I mean, for example, if I set it to 12 volt, then it will remain there at the 12 volt instead of varying above or below that value. So this goes up to approximately 27.5 volt when the mains voltage is enough. So at the moment you see it is at that 27.5 volt, and the current is 0 because I have not connected any load, and at the moment the it is operating in voltage mode, constant voltage mode, which is indicated by the this red LED. And now let's connect the full load. I mean by full load, full 4 ampere, and see whether it shifts to constant current mode or not. So I have connected a load, this load. This is a 4 ampere load. So at the moment the voltage is 27.5 volt, and now when I connected the constant current mode, LED has lightened up, and the voltage dropped to 9.9 volt, and the current drawn is 4.09 ampere. So it's working well. 4 ampere is the maximum limit that it can pass. So when I removed the full load, then the voltage has risen to 27.4 volt, and the current is 0. So it is working well. So let me show you what's inside this attachment power supply. I mean how I made the change. I made the changes so that it can work correctly. There are a few screws that I have to open to show you what's inside it, what changes I am done. At least my attachment power supply is working, and the other attachment power supply, which is a programmable high power and switch mode, is under construction. There is some delay, but hopefully I will complete it soon as well. So guys, just have a look. So this is the inside of the my testament power supply. Basically, there is a linear transformer on the bottom side, as you can see here, and its output had four tapes. So I neglected two tapes and only taken the other two tapes which were generating 30-volt AC. So 30-volt AC at normal to 30-volt mains voltage will produce a peak of around 40-volt DC. So uh, so when there is nothing connected, then the DC input voltage would be 40-volt DC. But I have installed the components, for example, the buck converter. As you can see here, I purchased it from Digilog, and then there is a variable that you can see inside. Beneath it is a variable that I constructed. The reason for constructing the variable was that 40-volt DC is above the maximum sustainable voltage that buck converter can have. Because although the Digilog and other websites show that this buck converter can be operated from 40-volt maximum DC and 8.2 ampere output, but after examining the buck converter and searching the its data sheet on the net, I saw that the supply to the op amps which are used inside it to control the current and the voltage and LEDs is powered from 78L05 SMD regulator. And when I explored the 78L05 data sheet, then it says that the maximum voltage that can be put on the input pins should not exceed 30 volt. So because of that reason, I cannot increase the voltage to 40-volt DC. So instead I use the already soldered 2305 three transistors that were working with this linear controller board. And I designed the circuit on a variable board so that they can be operated in the series pass regulator configuration, and it take 40-volt DC input from the capacitor. This is the capacitor, and 40-volt DC take 40-volt DC and produce at the output only 28 volt, approximately 28 volt DC. So 28 or 27.5 volt DC is good enough to be given to the buck converter while considering the absolute maximum rating of the 78L05 regulator, which is installed inside this buck converter. So I utilized this heatsink and the 2305 three transistors in parallel combination, which are producing approximately 27.5 or 28 volt DC. And that 28 volt DC, after passing through a fuse, they comes to the input of the buck converter, and the out of the buck converter goes to the output connectors. And in order to implement the variable voltage and variable current, there were two trim port potentiometers were installed on this side, one for voltage and one for current. I replaced these both trim pot potentiometers with these two 10 ton variable 10K potentiometers, and the result was very amazing. So then there is as I told you that there was 7 segment display uh, were installed on the front panel side previously, so that it can indicate the voltage and current reading. But because I told you that the potentiometer that I am using, as you can see, if you can see the blue color potentiometers, they are of large diameter, so they were not fitting, so I removed the this voltmeter and ampere meter and replaced it with the uh, small voltmeter. As you can see on this side, this is a small voltmeter and ampere meter, and it doesn't require external shunt up to 10 ampere. So this is the attachment power supply, and it's working as desired. And let me plug in once again, and also replace the fan as well, because fan was very dusty and was producing noise. So I replaced the 24 volt DC fan with the new one 24 volt DC fan. And the very board that I have constructed, they not only provide the approximately 24 volt to the fan, but also it is providing approximately 10 volt to the digital volt and ampere meter. So this way it is working. So guys, this was today's short video. So stay connected, and thank you very much.